So this is a question from JEE Advanced 2022. The question is from the chapter projectile, and the question is: a projectile is fired from horizontal ground with a speed v and the projection angle theta when the acceleration due to the gravity is g. Okay, the range of the projectile is g. Okay, it is given like this: a projectile is being projected with from the ground. So this is our ground. Let us pause. And a projectile is being projected from here with the initial speed that is equal to v with some angle theta. Okay, let us suppose this projectile is following a path like this. Okay, and it is given that when there is acceleration due to gravity g, the range of this projectile is d. Okay, now the situation is given like if at the highest point in its trajectory the projectile enters a different region where the effective acceleration due to gravity is g, that is equal to g by 0.81, then we have to tell, basically we have to find the new range of this projectile in that motion. So I will draw the diagram again here. Let us pause. This is our ground, and initially like our projectile is being projected, and let us suppose it is the highest point, that is h max, maximum height, and this projectile is being projected with an initial velocity of v with an angle theta with respect to the horizontal. Okay, now in the region that is on left side there is acceleration due to gravity g, and the region on the right side their acceleration due to gravity is g by 0.81. okay, now we have to find the new range here. So let us suppose this is our d dash. So here for the original case I can write directly what is the formula of this range in terms of v and theta and g. So range of the projectile when the acceleration due to gravity is g, so range of the projectile will be equal to, here d, that will be equal to v square sine 2 theta divided by g. So this is the formula for the range of the projectile and the acceleration due to gravity is g. Okay, let us suppose this is our equation number 1. Okay, now for this second case, like this is our second case, we know that half of the range will be equal to that d dash by 2, that will be equal to the half of this range, original range, that is equal to d by 2. So this will be equal to v square sine 2 theta divided by g, or divided by 2g. Okay, so this is the half of this range. Now basically we have to find this d dash by 2 in the next part, that where the acceleration due to gravity is g by 0.81. Okay, I will draw this situation here again. Like this is our situation on the right side where the acceleration due to gravity is different. Okay, so this is our ground. When the projectile is at the maximum height, at this point it will be having only the horizontal velocity. Okay, and that horizontal velocity is what? V cos theta. Okay, and the vertical velocity at this point, that is equal to vy, that will be 0. Okay, so basically due to this acceleration due to gravity, g by 0.81, okay, that is equal to 0.81, right? This will be the acceleration due to gravity felt by this projectile in the vertical motion. So I will be writing the equation for the vertical motion, and I will find out what is the time period of this projectile in this next region. So here if I write the equation of motion, that final speed will be somewhat we don't know. So here maximum height is h max. Also we know that the formula for maximum height is h max, that will be equal to v square sine square theta divided by 2g. So this is our maximum height. Okay. Now I can write the motion of equation for this projectile along this vertical line, vertical motion, that will be equal to v square minus the second equation of motion we can use here, that will be h is equal to ut plus half at square. Okay, so here h is equal to h max, and our initial velocity is 0, so this term will be 0, plus half into that acceleration due to gravity is 0.g divided by 0.81 into t square. So t square, from this t we have to calculate here. I will put the value of h max, that will be equal to v square sine square theta divided by g 2g, that will be equal to half of let us put the value of g here. Let us keep it like g only, g divided by 0.81 into t square. So 2 will be cancelled out from here, so we will be getting t square will be equal to 0.81 into v square sine square theta divided by g square. Okay, so from here we got the value of time for this projectile will be in the air, that will be equal to under root of this quantity. Under root we will be directly writing 0.9 into v sine theta divided by g. So this is our time period for which the projectile will be in the air in the next region. So here we can find out the range of this projectile, that is d dash by 2, this on the right side. So d dash by 2, I can directly write d dash by 2, that will be equal to the component of velocity in the horizontal direction at this point, that is v cos theta, into the time period for which the projectile will be in the air, that is t. Okay. Because in horizontal direction there is not any type of acceleration present in the system, so our d dash by 2 will be equal to v cos theta multiply, I will put the value of time from here, that is equal to 0.9 into v sin theta divided by g. Okay, so that will be equal to 0.9 dot v square, okay, v square sin theta cos theta divided by g. Okay, now we can find out the total range of this particle in that next part, that for our second case. So I will be writing the total range will be equal to d dash that is equal to d dash. Basically this is the part 2 for this. I can write it like d, not d dash by 2, but I should write it like I should write this term like d dash 2 instead of d dash by 2. So it will be like d dash 2, and here it will not be the half of this d dash by 2, basically d dash 1, yeah, first part of this range. So for total range we have to write here, we have to add both the quantities, so that will be d dash of 1 plus d dash of 2, that will be equal to the value of d dash of 1 will be equal to v square sin 2 theta divided by 2g okay, v square sine 2 theta divided by 2g plus this d dash of 2, that is equal to this 0.9 v square sine theta dot cos theta divided by g. Okay, so that will be equal to for sine theta we can write v square into 2 sine theta cos theta divided by 2g, that plus 0.9 v square sine theta cos theta divided by g. Okay, so here 2 will be cancelled out and this whole term will be equal to 1 plus 0.9, that will be equal to 1.9 v square sine theta cos theta divided by g. Okay, so this is the value of total range, that is equal to our d dash. So put it at like equation number 2, and what we got earlier is equation number 1, that is equal to d. So we just have to divide both the equations. So dividing both of these equations, dividing both the equations 1 and 2, we will be getting d dash by d, that will be equal to 1.9 v square sine theta cos theta divided by g divided by the value of d. Value of d will be equal to twice of v square sine theta cos theta, sine theta cos theta divided by g. Okay, so this whole term will be cancelled out, and here we will be getting 1.9 divided by 2. Okay, that what we can write 19 divided by 20. So if I solve this fraction, then I will be getting it equal to a value of that 0.95. Okay, so here the relation between that d dash and d will be equal to like d dash is equal to 0.95 times of d. So according to our question, this is the value of n that we had to find earlier. So this is the value of n, that is equal to 0.95. Okay, so this is the final solution for this question. Thank you.